Good morning, everyone. This is B. Ramarao from Government Polytechnic College, Station Ganpur. Today, our topic chemical bond and ionic bond. Today, we discuss about what is chemical bonding, how do formation of chemical bonding between atoms, how do formation of ionic bond in atoms. These topics from first year diploma students, first semester syllabus, subject code 104, chemical bond and ionic bond. Chemical bonding and ionic bond. Objectives. On the completion of this period, you would be able to know. On the completion of this period, you would be able to know. First one is chemical bond. What is chemical bond? How do you form chemical bond in atoms? Second one, electronic theory of valency. This theory was proposed by Cosell and Lewis. How to form chemical bond in molecule between the atoms can explained by this theory. Third one, ionic bond. What is ionic bond? How to form ionic bond between atoms? Fourth one, characteristics of ionic compounds. These topics discussed in this period. First one is chemical bond. Second one, electronic theory of valency. Third one, ionic bond. Fourth one, characteristics of ionic compounds. These topics discuss about chemical bond and ionic bond. Chemical bond. What is a chemical bond? A chemical bond is defined as the attractive force that hold two or more atoms together in a molecule or an ion. A chemical bond is defined as the attractive force that hold two or more atoms together in a molecule or an ions is called chemical bond. What is a chemical bond? The force of attraction between atoms of a molecule is known as chemical bond. The force of attraction between atoms of a molecule is known as chemical bond. The force of attraction between atoms in the molecule. Chemical bond, the force of attraction between an atoms or group of atoms that result formation of stable molecule is called chemical bond. Atoms of element are different elements combined to form molecule. The capacity of group of combined molecule themselves were given in the of valency. What is the valency? The number of hydrogen atoms or chlorine atoms or double the number of oxygen atoms with which one atoms of an element combined is called valency. The valency of electrons involving in formation of chemical bonding. The number of atoms of hydrogen are twice the number of atoms of oxygen that combined with one atom of element is called valency. The chemical bond formation because of between the atoms can be explained in terms of lowering of energy. Second one is electronic configuration. Atoms in the uncombined stage possess higher potential energy and are less stable. When atoms are uncombined, it have high energy and less stable. When it is combined to form molecule, they get more stability because of stable electronic configuration in its valency cell. So, which atoms are unstable, those atoms are combined together to form a stable molecule when it gets stable electronic configuration in its valency. Why do atoms combine together? Atoms combine because they are not stable. Atoms in the uncombined state possess high potential energy and are less stable. Atoms combine because they are not stable unless their valency orbital is full of electrons. In order to fill this outer orbital, they will share or give or take electrons from other atoms. Then it gets stable electronic configuration in its valency cell. Then atoms are combined. Atoms in uncombined state, it possesses higher potential energy and are less stable. But when they combine to form molecule, they get more stability and potential energy of system is lower. During the bond formation, energy is released. That is, bond formation is exothermic reaction. Atoms of noble gases are stable because of stable electronic configuration of in its valency cell. The inert gases, due to the stable valency electronic configuration, that is NS2 NP6 configuration. This configuration is called octet configuration. Atoms of other elements tends to attain this noble gas configuration in their outermost orbital to get stability. So, Which atoms are unstable? Those atoms are combined together to form stable electronic configuration in its valency cell, that is NS2-NP6 configuration. Which is stable electronic configuration atoms are does not form chemical bonding. How do atoms combine? Atoms combine in the following two ways. First one is transfer of one or more electrons from the valency cell of one atom to the valency cell of another atom. Transfer of electron between the atoms to form stable electronic configuration in its valency cell to form a chemical bond. Transfer of one or more electrons from the valency cell of one atom to the valency cell of another atom. Second one or two or three electron pairs of valency cells of both the combining atoms are shared between them. One is transfer of electron between the atoms to form stable electronic configuration of both atoms. Second one is mutual sharing of electrons between the atoms to form a stable electronic configuration in its valency cell. These two types of electron transfer between the atoms to get stable electronic configuration then form a chemical bond. First one is transfer of electrons. Second one is sharing of electron between the atoms. These two types of bonds formed between atoms. Chemical bond. Now, the attractive force which holds various constituents, atoms, ions, etc. together in different chemical species is called chemical bond. The attractive force of atoms together in different chemical species is called a chemical bond. Is called chemical bond. The attractive force which hold various constituents together in different chemical species is called chemical bond. Is called a chemical bond. Now we discuss electronic theory of valency. Electronic theory of valency. This electronic theory of valency proposed by Cosell and Lewis. Electronic theory of valency proposed by Cosell and Lewis. Cosell and Lewis approach to chemical bonding. Cosell, Lewis approach to chemical bonding. Cosell and Lewis in 1916 independently proposed a theory to explain chemical bonding in terms of electronic distribution based on Bohr's atomic model. This theory is also called electronic theory of valency. Electronic theory of valency. Lewis pictured the atom in terms of positively charged kernel, the nucleus plus nucleus plus the inner electrons and the outer shell that could accommodate a maximum of 8 electrons. A maximum of 8 electrons. Lewis postulated that atoms achieve the stable octet when they are linked by chemical bonding. When they are linked by chemical bonding. And this theory, given some important points, are called postulates of electronic theory of valency. This Lewis can explain atoms sharing of electrons between the atoms. Lewis postulates that atoms achieve the stable octet when they are linked by chemical bonding. How to form stable electronic configuration? The electron present in outermost orbit of an atom take part in bond formation. These electrons are called valency electrons and the outermost orbit is called valency orbit. Outermost orbit is called valency orbit. The bond formed as a result of electronic attraction between positive and negative ions was termed as the electrovalent bond. The electrons present in the outermost orbit of an atom take part in bond formation. These electrons are called valency electrons and the outermost orbit is called valency orbit. Noble gases like helium, neon, argon, krypton, xenon, radon. These all are noble gases. These elements are stable. These elements are stable and chemically inert due to containing of fulfilled valency cells, that is NS2-NP6 configuration. It is very stable arrangement. Atom of other elements tends to attain 8 electrons in their valency orbit to get stability. This tendency is responsible for the bond formation. According to electronic theory of valency, a chemical bonding atoms can combine either by transfer of electrons from one atom to another atom or by sharing of valency electrons in order to have an octet in their valency cell. This is known octet rule. What is octet rule? A rule which states that an atom must possess 8 electrons in its valency cell for stability is called octet rule. For stability is called octet rule. According to electronic theory of valency, chemical bonding formed by transfer of electrons between the atoms or sharing of electrons between the atoms to get 8 electronic configuration, that is NS2-NP6 configuration in its valency cell, is called octet rule. Octet rule. When atoms are unstable, those unstable atoms get 8 electronic configuration in its valency cell for stability. How do form 8 electronic configuration in its valency cell? By the transfer of electrons or by sharing of electrons. By the transfer of electrons or by sharing of electrons between the atoms to form 8 electronic configuration in its valency cell is called octet configuration. These 8 electronic configuration formed in atoms by the transfer of electrons or sharing of electrons between the atoms. The attaining of 8 electron configuration in the outermost orbit by loss of electron or gain of electrons or sharing of electrons to get stability is called octet rule. But elements near to helium get stability by having a configuration of 2 electrons in the first orbit. So, according to electronic theory of valency, the atom must get 8 electrons in its valency shell by the transfer of electrons or sharing of electrons between the atom to get stability. These are Cosell and Lewis given by electronic theory of valence. In this theory, the electron present in valency shell are involved in chemical bond. The electrons present in the valency shell are involved in chemical bond. The atom of zero group or noble group or eighth group elements are stable due to stable electronic configuration, that is NS2 NP6 configuration. Except inert gases, the atom of other elements attain stability by acquiring nearest noble gas electronic configuration. How to get 8 electronic configuration in its valency shell? By the transfer of electrons or sharing of electrons between the atom to get 8 electronic configuration. This 8 electronic configuration is called octet rule. What is octet rule? A rule which states that an atom must possess 8 electrons in its valency shell for stability is called octet rule. This octet rule formed by transfer of electrons or by sharing of electrons. Ionic bond is formed by transfer of electron and covalent bond is formed by sharing of electrons. So, chemical bond formed by transfer of electrons between the atom to form ionic bond, sharing of electrons between the atoms to form covalent bond. These two types of bond formed between the atoms. Now, we discuss ionic bond or electrovalent bond. Ionic bond or electrovalent bond. Ionic bond. Most ionic compounds have cations derived from metallic element and anions from non-metallic element. Two atoms are involving in formation of ionic bond. One is metallic atom, another one is non-metallic element. These ionic compounds have cation and anions. The positive charged particles are called cations and negative charged particles are called anions. The cations and anions involving in formation of ionic bond. These compounds have cations derived from metallic elements. And anions from non-metallic elements. Metallic and non-metallic elements. Ionic compounds in crystalline state consist order of three-dimensional arrangement of cations and anions held together by Coulombic interaction energies. How to form ionic bond? A chemical bond formed by complete transfer of one or more elements, one or more electrons from one atom to another atom is called ionic bond. A chemical bond formed by complete transfer of one or more electrons from one atom to another atom is called ionic bond. The strong electrostatic force of attraction between opposite charged ions formed by transfer of electron is called ionic bond. The electrostatic force of attraction between opposite charged ions formed by transfer of electrons is called ionic bond. This ionic bond formed between two atoms. If electronegativity difference is more than 1.9. Electronegativity difference is more than 1.9. It is formed between a metal with low ionization energy and a non-metal with high electronegativity. The formation of ionic bond takes place in three steps. First one is formation of cation, formation of anion, formation of ionic bond. Formation of cation in sodium chloride molecule. Sodium chloride molecule. In sodium chloride molecule formed between ionic bond, sodium atom and chlorine atom. Chlorine atom. When an atom of an element loses electrons from its outermost shell, it forms a positive ion. When an atom of an element loses electrons from its outermost shell, it forms a positive ion. Sodium metal combined with chlorine gas to form a crystalline solid, sodium chloride. For example, atomic number of sodium is 11 and so its electronic configuration is 1s2, 2s2, 2p6, 3s1. So 2, 8, 1. In first cell have 2 electrons, second cell have 8 electrons, third cell have only 1 electron. The electronic configuration of sodium is 1s2, 2s2, 2p6, 3s1, 2, 8, 1. It readily loses valency electrons to get nearest noble gas neon configuration, that is 1s2, 2s2, 2p6. Then form a positive sodium ions. In sodium present 2, 8, 1 electronic configuration. When it is loss of one electron in its valency cell to get nearest inert gas neon configuration. Neon configuration. Here we see this reaction sodium electronic configuration 2H1 1s2 2s2 2p6 3s1. This sodium atom is unstable. When it loses off one electron in its valency shell to get stable electronic configuration of neon 1s2, 2s2, 2p6. Then sodium loss of one electron from its valency shell to form Na plus one electron. Na plus is called sodium cation. Its electronic configuration 1s2, 2s2, 2p6, that is neon configuration. Then it gets nearest inert gas configuration. When an atom of an element gain electron from its outermost shell, it forms negative ion. The negative ion is called anion. The electronic configuration of chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. Its electronic configuration 287. So this chlorine atom is unstable. Its valence shell have only 7 electrons. It less than 1 electron to get stable electronic configuration of octet rule, that is ns2 np6 configuration. Then chlorine atom gain of 1 electron from another atom to get nearest inert gas argon configuration, that is 1s2, 2s2, 2p6, 3s2, 3p6. Then it is stable. So it gained 1 electron from sodium atom. It gained 1 electron from sodium atom to get nearest inert gas argon configuration. Then form a negative charged chloride ion is called anion. Anion form when gain of an electron from its valency shell to get stable electronic configuration of argon configuration. This chlorine electronic configuration 287. 287. That means 1s2, 2s2, 2p6, 3s2, 3p5. It gain up 1 electron from sodium atom to get stable electronic configuration of argon configuration 1s2, 2s2, 2p6, 3s2, 3p6. Then form a negative charged particle is called anion. That means Cl minus. Here we see reaction chlorine element 287 gain of 1 electron from sodium atom to get stable electronic configuration of in valency shell Cl minus chloride ion 288. 288. If the number of electrons in the outermost orbit of an atom are 5, 6, 7, the atom tends to gain electron and form negative ion. If the number of electrons in the outermost orbit of an atom are 5, 6, 7, the atom tends to gain electrons to form negative ions. If the number of electrons in the outermost orbit of an atom 5, 6, 7, the atom tends to gain electrons to form negative charged parts. The chlorine atom will have gain one electron in its outermost orbit shell to form a negative ion and attain octet configuration 2, 8, 8, similar that of inert gas argon configuration. The chlorine atom will gain one electron from sodium atom in its outermost orbit to form negative ion is called anion and attain octet configuration 2, 8, 8, that is 1s2, 2s2, 2p6, 3s2, 3p6. Similar to that of inert gas argon configuration. Argon configuration form chlorine atom when gain of one electron from sodium atom. When sodium atom and chlorine come in contact, each sodium atom give up an electron to become a sodium cation and chlorine ion gain one electron to become a Cl minus ion. One is positive cation and another one is negative anion. So NaCl formed will have no net charge. Here we see sodium atom. Sodium in first cell have 1s2, only 2 electrons. Second cell have 2s2, 2p6, that is 8 electrons in its valency cell, second cell. In third cell have, that is valency cell, have only 1 electron in sodium atom. Those electrons when lost in valency cell to form nearest inert gas neon configuration, that is 1s2, 2s2, 2p6, 2, 8 configuration. Chlorine. Here we see chlorine electronic configuration 1s2, first cell have only 2 electrons, 2s2, 2p6, second cell 8 electrons, third cell 3s2, 3p5. It have only 7 electrons in third cell. One electron gained from sodium atom to get stable electronic configuration of argon. By loss of one electron in its valency cell from sodium atom to get positive charged particle, when gain of one electron from sodium atom, chlorine get negative charged particle of anion. These both are opposite charged particles attract together to form a stable molecule is called sodium chloride. Sodium chloride. The opposite charged Na cation, that means Na plus, and Cl minus, that is anions, held together by electrostatic force attraction between to form ionic bond. To form ionic bond. By the transfer of electron from sodium to chlorine to get positive and negative charged particle, these particles attract together to form a chemical bond is called ionic bond. Second one is magnesium oxide. Magnesium electronic configuration 282. 282. First cell 2 electron, second cell 8 electron, third cell 2 electron. Loses 2 electrons and form magnesium cation, that is Mg plus 2. Similarly, oxygen atom have 1s2, 2s2, 2p4. It have 2, 6 configuration. Valence cell have only 6 electrons. It gain of 2 electrons from magnesium to form magnesium anion. When magnesium cation and oxygen anion come near each other due to opposite charged electrons, these ions attracted by each other to form ionic bond, to form magnesium oxide. Magnesium in its valence cell have only 2 electrons. Those electrons lost in valence cell to form nearest inert gas neon configuration. Similarly, oxygen atom have in its valence cell 6 electrons. 2 electrons gained from magnesium atom to get nearest inert gas neon configuration. By the transfer of electrons between magnesium to oxygen, then form magnesium cation and oxygen anion. These opposite charged ions attract together to form ionic bond in magnesium oxide. Mg plus of O2 gives magnesium oxide. Properties of ionic compounds. Ionic bond produce unique physical structure and therefore other compounds. Ionic compounds are available in crystalline solid state. Ionic compounds are crystalline solids due to strong attraction between opposite charged ions and regular arrangement of ions. A crystalline lattice is a three-dimensional geothermal arrangement of particles. Lattice energy. The energy required to separate one molecule of ions of ionic compounds. Ionic compounds having high melting point and having high boiling point due to strong attraction between ions. In a crystalline lattice, each positive ion is surrounded by negative ion and each negative ion is surrounded by positive ions. A crystalline lattice, each positive ion is surrounded by negative ion and each negative ion is surrounded by positive ions. Positive ions. Ionic compounds are soluble in polar solvent. These compounds are soluble in polar solvent. What is polar solvent? Like water. This is due to hydration of ions and energy released is sufficient to break ionic bond. Ionic compounds are soluble in polar solvent. Ionic compounds are non-conductors in solid state due to absence of ions. When it is conductor in aqueous solution state due to presence of free ions. Ionic bond is non-directional and do not show isomerism. The reaction is in ionic compounds very fast as free ions are present in aqueous solution. These are properties of ionic compounds. Ionic compounds are available in crystalline solid state. Ionic compounds have high melting and high boiling point. Ionic compounds are soluble in polar solvent. Ionic compounds are non-conductor in solid state and conductor in aqueous solution state. Ionic bond is non-directional, hence ionic compounds do not exhibit isomerism. The reaction in ionic compounds very fast as free ions are present in aqueous solution. These are characters of ionic compounds. Frequently asked question about this topic. Frequently asked questions about this topic. First one is, what is chemical bond? What is chemical bond? The force of attraction between the atoms is called chemical bond. Explain electronic theory of valency. This theory was proposed by Cossel and Lewis. By the transfer of electrons or sharing of electrons, atoms get stable electronic configuration in a valency cell. By the transfer of electrons to form ionic bond. By the sharing of electrons between the atom to form covalent bond. Explain formation of ionic bond in sodium chloride and magnesium oxide. Sodium in its valency cell only 1 electron. Chlorine it have valency cell 7 electron. By the transfer of 1 electron from sodium to chlorine, then form sodium cation and chlorine ion, anion. Both ions get stable electronic configuration of neon and argon configuration. These ions attract together to form sodium chloride stable molecule. Magnesium in its valency have 2 electrons. Chlorine, oxygen in its valency 6 electrons. 2 electrons transfer from magnesium to oxygen to form ionic bond in magnesium oxide. Write the characteristics of ionic compounds. Ionic compounds are crystalline solid. It have high melting and high boiling point. These are soluble in polar solvent. These are non-conductor in solid state. These are non-directional bond. The reaction between ionic compounds very fast reaction. These are some characters of ionic compounds. Thank you very much.